We're moving on to our next one. Our next one is from Duncan Gobbs. Duncan, thank you. This is a beautiful question. It deals with analytical geometry or coordinate geometry, and it is for a total of 16 marks. Let's look at the screen. They tell us the following. They say, in the figure, a circle M is drawn with its center obviously then at M. They don't have to, let me change color here. They didn't have to tell us that. Okay, the moment they they have to tell us it is the center, sorry. So the equation of the circle that they gave us for M, that equation is given to us as x plus 2 squared plus y minus 1 squared, which is r squared. Now we know from that we can read off the center. Okay, so maybe they're going to ask us for r. Let's see what's going to happen. Then they say S is the point 1 and minus 2. Now point S is, S is over there, 1 and minus 2. Then they say SR, that line, is indeed a tangent to both circles. Now that is very helpful. The moment we have a tangent and a radius, we know they are perpendicular to one another. So we can say that there's a right angle at the point S between the tangent and that radius. Okay, let's see the first question, 6.1. They ask us, write down the coordinates of M, which is the center of the circle, and then also find the radius of that circle. Okay, so let's have a look. M, the center M, we can read off. Now remember, the only thing that you must remember is that this sign changes from equation to point. So that is minus 2. There's a minus 1. It becomes a 1. Now we don't have r squared. So to find r squared, we need one more bit of information. And we are lucky because they gave us the tangency point. They said to us that the point S, which lies over there, lies on the circle, both circles, it is the tangency point. So if I go to this equation and I make x equal to 1, I get 1 plus 2 all squared, plus the y value I need to make minus 2 minus 1 all squared, and that gives me r squared. Now, if your eye is trained to see these things, you'll see that this is a 9 plus a 9. Those are exactly the same, gives r squared. So r squared is equal to 2 times 9, which means r will be the square root of that number, which is 3 root 2 in surd form. Remember, you had r squared. So you've got to take the square root on both sides to write down the radius. So our answer was that the center lies there and our radius is over there. Duncan, I hope that made sense to you. It's for 4 marks. The second part of this question, part 6.2, for another 4 marks. Now they ask us for the equation that lies between those two tangents. Now remember, an equation is a line, and they ask us to leave it in the form y equals mx plus c. Okay, so what do we need? We're looking for the equation of a line. I need a gradient, and I need something else as well, either a point on the line or I need the y-intercept. Okay, let's see what we've got. We've got the point. The point S is the point 1 and minus 2. And I just found that this is the point minus 2 and 1. And I also know that this radius is 3 times the root of 2. So I've just put that information on there so that in case we need it, we know it's there, else we're going to forget that we've got the information. Now that was important, folks, because if you look at MS, MS is perpendicular to the tangent. So if I can find the gradient of MS, the line segment MS, then all I need to do is reciprocate it for the gradient of the tangent. Okay, reciprocate and multiply by -1. Why is that the case? because the tangent is perpendicular to the radius at the point of contact. It's a geometry theorem from grade 11. Okay, let's find that gradient. 1 minus minus 2, be careful of that double negative, over minus 2 minus 1. So I started at m, go to s, so I must do that for y and for x. So here I get 3 over minus 3, and that, let's just see, this is plus 3 over minus 3, and that makes it minus 1. Now that's the gradient of this radius on our diagram. What do we want? We want the gradient. There's the radius there, and there's the tangent. Okay, so we need to turn it on its head and multiply it with minus 1, which will then make from here the gradient of the tangent equal to a positive 1. Okay, now we know the gradient. We have the point of tangency, and we have the gradient. Oh, that's easy enough. We've got a point and a gradient. So what do? We go into our final phase for this question. We say y minus the minus 2 over x minus 1, as if we are finding the gradient between a variable point x, y, and that point. So that gradient we know is 1. There we go. All that is now left for us is to clean that up. Okay, I'm going to distribute the brackets, get the y on the one side so I can leave it in the form mx plus c. Let's have a look. This gives us y plus 2, which is equal to x minus 1. The 2 must go to the other side, so y is equal to x minus 2 minus 1 gives us the equation of the tangent as y is equal to x minus 3. If we need it, we write it on our diagram. We've got more. You can see the more questions we answer here, the more information we get about our diagram. The last part is a stunning question for 8 marks. They say, the circles with centers P and M. Now, if you look at the center P, it's given as A and B. They say touch externally at point S, which is over there. Now, having said that, folks, having told you that you've got a center at M, a tangency point at S, and another center at P, means the following. It means that, let me get the line, that, let me just get another color, that those things lie on the same line. This center here, this point of tangency, and the center here at P lie on a line. And that line, we can find its equation. Now, why is that important? Look at your point here. Look at the point where they tell us the center lies. We don't know what A is and we don't know what B is. But because the point lies on that line, my line is not very accurately drawn, I know the gradient of that line. I found that gradient. That gradient was minus 1. And I know a point through which the line will pass. So I can find the relationship between A and B in the center of the bigger circle. Okay, let's read on. Let's see if that's necessary. They say, okay, they touch externally. SR is a tangent to both circles, and now they give us some interesting information. They now say to us for 6.3 that MS to MP is the same as 1 to 3. So let's see what that means. That means this little line here, the ratio between that and this distance is 1 to 3. Okay, we already have that distance there. That distance is 3 multiplied by root 2. So this distance will be 9 multiplied by root 2 because it's 3 times bigger. They told us that. They said the ratio is 1 to 3. Okay, so we know that relationship. Then the question finally asks us, find the coordinates of point B. So we're going to try and do that as quick as we can. The equation of the line that goes through the point P, I'm just going to put a P there. Okay, it has a gradient of -1 and it goes through -2 and 1. Okay, so -2 and 1, and it has a gradient of 1. So again, I treat it as if I have a variable point x, y that lies on that line. Okay, so I can say then that y minus 1 over x minus -2 becomes x plus 2 is equal to -1. Sorry, I forgot the negative over there. Okay, so with that then, I can say that y minus 1 is nothing other than minus x minus 2. The -1 comes over. I have minus x minus 1. Now look at the poetry here, folks. That tells us that if we go back to point P, we've got the relationship. The relationship for point P is x, and what did we find? Minus x minus 1, and minus x minus 1. So now I can start working with distances. I've got the distance between M and S. I have the distance between S and P. No, I don't have that distance. I know that it's 3 times the length. So let's go and let us finish this question off. MS I have. MS was the short line, so we're going into phase 2 of the question. So we know that 3 root 2 to MP is equal to 1 to 3, just to show you what we're going to work with. So MP over that, MP over 3 root 2 is equal to 3 over 1. Okay, and to find MP, that's the distance from the one center to the other center. That will be 9 root 2. Okay, so I've got the distance from this center to this center was actually the distance they gave me as 3 times that small distance. I've got that. Okay, I have the point there. I have the relationship here. I can work with that information. Okay, so I know the point P has x minus x minus 1, minus x minus 1. Sorry, let me just get rid of that bit. Is minus x minus 1. And then I know that my coordinate pair at M was, what was it? It was -2 and 1. Okay, so I'm going to say the distance between those two is the 9 root 2. But I know I'm going to use the distance formula, so I'm going to say MP squared, which is equal to x minus minus 2 is x plus 2 all squared, plus minus x minus 1 minus another 1 all squared. And I know that that will be this value squared. So 9 squared is 81 multiplied by 2. Now, folks, you don't want to do unnecessary work here. You are not going to distribute those 2 brackets. Look at the brackets. Look closely at them. They are exactly the same thing. Look at this. I have x plus 2 over here, which I don't want to touch. Plus, now if you remove a negative there and you square the negative, it becomes a positive. So it's x and there's 2 ones, so x plus 2 all squared, which is 81 multiplied by 2. So what do I get? You will notice that I'm not multiplying that out. So 2x plus 2 all squared is 81 times 2, and beautiful, look at how it simplifies itself. Okay, so don't forget now that x plus 2 is the square root of that which is plus or minus 9. So that leaves me with an x value of minus 2 plus or minus 9, which we now have to make a choice between. The final answer is going to be minus 11 or the x value is going to be minus 2 plus 9, which is 7. Now we can choose any one of the two. Let's see from our diagram which one applies. If we go all the way back to the diagram, well, this x value lies on the positive side of the x-axis, so we're definitely not going to work with the minus 11. Again, it is a solution to the equation, but it does not apply to the graph that I want to work with. So I know that x is 7, so I can say, beautiful, then p will be 7. And remember what it was? It was minus x minus 1. So it's minus 7 minus 1, which is indeed minus 8. All that work, all that work for 8 marks. Okay, beautiful question, Duncan. Thank you for that. Folks, as you can hear, my voice is taking strain, so we're going to take a short break and we'll be back with you now.